What appears to be correct for one person may appear to be wrong to another person. Now you may ask, how can a sentence be correct for one person and wrong for another? How? How is this possible? Consider the following examples. Now left and right are relative. Here is Mr. Ramu and Mr. Rajesh who are walking in the opposite directions on the road. The tree appears to be on the right of Mr. Ramu, whereas it appears to be left of Mr. Rajesh. We have another example which is discussed in the textbook. Here is Mr. Person B and Person A, and Mr. B says the tree is on my left, and what Mr. A says, no, this tree is on my right. The argument continues. B says that it is on his left, while A says that is on his right. Left and right. Here, what appears to be right for one person may appear to be left to another person. So left and right are relative. This is another example. Here we have different people on the earth. In the figure we show only 4 people, A, B, C and D. When we ask who is up, the person A says it's me and all others are down. Children, what do you say? Is A right? Give the answer loudly. If we look from D's place, D appears to be up while the other 3 people appear to be down. So up and down are relative. Here is another example. Here are 2 people who are working, painting a building, and there is a place where paint has to be done. Mr. Raju has to move down to reach the place to be painted, while Mr. Ramu has to move up to reach the same place to be painted. So to reach the same place, one person has to move up, the other person has to move down. So up and down are relative. What appears to be up for one person may appear to be down for another person. So up and down are relative. Consider another example. Here there is a bus which is moving from Hyderabad to Karimnagar, and there are passengers. I hope many of you have travelled from Hyderabad towards various cities. Look at the conversation between 2 people. Passenger 1 says, which stop is coming next? Passenger 2 says, it's Siddipet. Passenger 1 asks, when will Karimnagar come? Passenger 2 says, in about an hour. Passenger 1 says, oh, thank you. Children, I would like to remind you, whenever we take a favor from people, we have to thank them. Let us observe the conversation between the passengers once again. Passenger 1 said, which stop is coming next? Passenger 2 said, Siddipet. Now I ask you a question, children. Can Siddipet come or go anywhere? Is that possible? Children, you may have seen different places. Did you observe any time a place moving from its place? That is, Siddipet moving or coming or going? Not possible, right? Any child will say, Siddipet can neither go nor come. For these passengers, when they are travelling in the bus, the places appear to be coming and going, and hence for them it was right. But for us, Siddipet neither comes nor goes. According to the passengers, it was correct to say Siddipet is coming. This is because all passengers along with the bus are moving. So motion is relative. Motion and rest are relative. So let us define what is motion. An object is said to be in motion if its position changes with respect to an observer or surroundings and time. An object is said to be in rest if its position does not change with respect to an observer and time. Look at these pictures. These pictures show that these animals are in motion. Look at these buildings. They never appear to move because they are fixed to the ground. Let us consider another example. Here is a plane where all the passengers are flying. Inside the plane, we never feel that the objects are moving, whereas all these people along with the plane are flying from one city to another. Children, let us look at the definition of motion and rest once again. Motion: an object is said to be in motion if its position changes with respect to surroundings and time. And rest: an object is said to be in rest if its position does not change with respect to an observer and time. Children, now we are able to say whether given an object is in motion or at rest. Now consider when objects are moving, what happens. Imagine a rabbit moving from point A to point B along the path A, P, Q, R, B. The length of this actual path travelled is called distance. Consider another example. Here is a goat and a cow. A goat has moved from point A to point B along the shown path, and a cow has moved from point P to point Q. Looking at the figure, we can say which one has travelled a greater distance. It is goat which has travelled a greater distance. And how are we able to do that? It is because simply comparing the lengths of the two paths, we can say here goat has travelled a greater distance. Here is another example where goat and cow have moved again, but in different paths now. To find out which one has travelled a greater distance, we have to measure the distances in order to arrive at the right answer. Children, you may have seen measurement of lengths in various cases in your life. Maybe when you are giving measurements for getting clothes stitched in a tailor shop. Maybe you have seen people constructing houses. There the masons may have used the tape. Measurement is a very important thing in our life. So let us consider some examples. For small distances we use a ruler. You may have used in maths for drawing straight lines as well as in constructions. How do you measure when the lengths are little longer? We use tape. And for lengths which are even more longer, so we may use different machines. Here is an example where an engineer is measuring the distance. We often see this during construction of dams or roads, etc., where engineers use specific devices to measure long distances. For even larger distances, we can use electronic survey equipment. After measurement, we have to use specific units, because whatever measurement is being done, you have to express it correctly. We have different units for distance. SI unit is being meter, and other units are millimeter, centimeter, kilometer, etc. I would like to introduce some units which are much bigger than we imagine. One is astronomical unit, which is the average distance between the sun and the earth. We know that earth is moving around the sun. Actually, it will be moving in elliptical orbit. So the distance between sun and the earth is not the same throughout the year. So the average distance is considered to be the astronomical unit. I would like to introduce another unit, which is light year. Light year is the distance travelled by light in 1 year. Light travels at an amazing speed of 3 lakh kilometers per second. Light is assumed to be the fastest in this universe. It travels at about 3 lakh kilometers per second, by which it can go around the earth 7 times in a second. Children, just imagine if you are moving from Hyderabad to Tirupati or Bombay or Delhi by train. By train it will take several hours to travel few hundreds of kilometers. Imagine you are traveling from Hyderabad to US, which is on the other side of the globe. It will take nearly 16 hours non-stop. But light can travel 7 times around the earth in just 1 second. So that's the speed of the light. And if at this speed, if light is traveling for 1 year, imagine the distance. Light travels at 3 lakh kilometers every second. At this speed, light can go 7 times around the earth in 1 second, if only it can bend. We all know that light travels in straight lines, it can never bend. Light year, which is equal to 9.46 into 10 power 12 kilometers, this is the distance which is traveled by light in 1 year. Children, I would like you to imagine an object which is farthest from you, which is very far from you. Can you guess? Children, we cannot imagine the farthest objects in this universe because we don't know the ends of this space. Children, we see many stars at night. Children, can you name the star which is nearest to us? The nearest star is Sun, and the next nearest star is Alpha Centauri. It's a 3-star system which is 4.37 light years away from us. Children, I would like to tell you one thing. If anything happens at that place, that is, if the star explodes, we come to know that after 4.37 years, because whatever happens there, the light which comes from that point to us, it will take 4.37 years. Let us see another unit, that is parsec. 1 parsec is 3.26 light years. Our Milky Way galaxy is nearly 60,000 parsec wide in diameter. Children, now we have discussed different units. Now we may often get confused which units to be used. If we are using small objects like pencil, etc., we may use the units centimeter, inch, etc. If you remember, the lengths of phones, smartphones, are expressed in inches, even for TVs. If we are using a little bigger objects, we can use the unit meter. A sari will be about 6 meters in length and nearly 1 meter wide. Some other units, if we are looking at door or a table or a cot, we express the lengths of these objects in feet. Children, what about the distances between 2 cities or villages? How do you measure them? We use kilometers to measure the distances between any 2 points in the map. We use kilometers as the unit to express the distance between any 2 places. Children, now we have seen that motion is relative. We also have discussed distance. Now let us do few numericals. Here is a numerical where an object has moved from point A to point B along the given path. Now quickly calculate the distance traveled by the object. The distance between A and B is given by the total length of the path, that is 5 meters plus 12 meters, which is equal to 17 meters. Let us do another numerical. Here again an object has moved from point A to point B along the given path. Here AP is 15 meters, PQ is 8 meters, QB is 9 meters. So the total distance has to be 15 meters plus 8 meters plus 9 meters, which comes out to be 32 meters. Now children, consider the same path of the rabbit which has moved from point A to point B. Irrespective of this path, there is a quantity which is called displacement. Displacement is the change in position of an object in a particular direction. When the object moved from point A to point B, here when an object has moved from point A to point B, here the ray AB gives you the displacement. Children, we often find quantities which do not have direction, example mass, temperature, etc., where the quantities have magnitude only, they do not have any direction. Here the displacement which we have considered has direction. The direction of displacement in this example is from A to B. So any physical quantity which has direction is called a vector. Children, in the same figure, can you tell me which is greater, distance or displacement? Can displacement be greater than distance? Is that possible? Clearly it is not. Displacement is the shortest distance between A and B, as it's a straight line joining A and B. So we define displacement as a change in position in the specific direction. Children, we have discussed distance earlier. In the same numericals, let us calculate the displacement. In the earlier question, where we found distance between A and B, we got distance between A and B to be 17 meters. Now let us calculate the displacement. Here AC is perpendicular to BC. We can consider ACB as a right angled triangle. So to find out the displacement, that is from A to B, we use Pythagoras Theorem. So AB being hypotenuse, AB square should be equal to AC square plus CB square. By substituting the values, we get AB square equal to AC square plus CB square. AB square is equal to 25 plus 144, which comes out to be 169, and AB is equal to 13 meters. So the displacement from A to B is 13 meters. If you compare, distance is 17 meters whereas displacement is 13 meters. The displacement is the shortest distance between the starting and the final point. Let us do another numerical. Here the object moved from point A to point B along the path APQB. We have already calculated the distance from point A to point B, which is 32 meters. To find the displacement between point A and point B, we can select a part of the figure. So we can select ACB such that AC is perpendicular to BC. ACB forms a right angled triangle, and hence we can use Pythagoras theorem. By geometry, we can find that AC is 6 meters, CB is 8 meters. Hence, by using Pythagoras theorem, AB square is equal to AC square plus CB square. AB square is equal to 6 square plus 8 square, which is AB square equal to 36 plus 64, and AB square is equal to 100. So AB is 10 meters. So the displacement is 10 meters, whereas the distance is 32 meters. Children, consider a goat and a cow again. Here let us give them a task to travel 100 meters. Let us see which one will travel first. Now children, can you tell me which one will usually travel faster, a goat or a cow? Yes, a goat will travel faster than a cow. Okay, in this example, we have given a task for cow and a goat. A goat has to travel from point A to point B. and cow will travel from point P to point Q. In our experiment, we found that goat has taken 100 seconds, whereas cow has taken 150 seconds. Now if we look at these two, cow has taken more time to travel the same distance. So we can say goat has covered the distance quickly, or goat has traveled with a greater speed. So speed is the rate of distance covered. So we can calculate speed by using the formula distance covered by time taken. The units are meter per second or kilometer per hour.
Let us calculate another numerical on speed. Find the speed of the object which has travelled from A to B covering 50 meters in 10 seconds. Here the distance is 50 meters, time taken is 10 seconds, and the formula for speed is distance covered by time taken. Substituting the values, we get speed is equal to 50 by 10, which is 5 meters per second. So here the speed of the object is 5 meters per second. Children, you can try these questions. Find out the displacement covered by the earth in 1 year revolving around the sun. Also calculate the displacement of your house in 1 day. You know that earth rotates. Along with the earth, your house also rotates. So find out the displacement covered by your house in 1 day. Children, let us see some of the fastest animals. On land, cheetah is the fastest. It can move at a speed of 110 km per hour. In water, black marlin is the fastest fish. It can swim at a speed of 130 km per hour. In air, peregrine falcon is the fastest bird. While hunting, it can dive at a speed of over 350 km per hour.
Children, let us revise now what we have learned. We have learned that left and right are relative. What appears to be left for one person may be right for another. We have also seen up and down are relative. We have also seen motion and rest are relative. Then we have discussed motion. An object is said to be in motion if its position changes with respect to an observer or surroundings and time. Rest. An object is said to be in state of rest if its position does not change with respect to an observer and time. We have discussed distance, that is the length of actual path travelled. Then displacement, that is change in position in a specific direction, or the shortest distance between starting and final points. Then we discussed speed, which is distance covered by time taken. Children, I hope you have understood these concepts, and what I want you people to do is take the textbook, work out the numericals, discuss the same things with your friends, and any doubts which you have, you can get it clarified with your teachers. Thank you.